The average person consumes and inhales 330 microplastic particles daily. Microplastics are found in polar ice, tap water, beer, honey, salt, and in the bodies of sea turtles and mosquitoes. Tea pyramids leave billions of plastic particles in tea. After brewing, the plastic bag, which eventually breaks down into small pieces, was even found at the bottom of the Mariana Trench. It turns out that microplastics are already affecting all global processes. That sounds scary, but there is almost no research on whether microplastics directly harm human health. No one wants to fund them. Let's examine the dangers of plastic pollution and what's happening in Baikal, the Baltic Sea, and the Arctic. Plastic doesn't literally decompose. It's durable and slowly breaks into smaller particles. Microplastics are plastic pieces between 5 millimeters and a micrometer in size. That's 40 to 120 times thinner than a human hair. There are even smaller elements called submicroplastics and then nanoplastics. They are virtually unstudied, although it is already known that such particles can penetrate cell membranes. The exact harm they cause to living organisms is still unknown. People can also inhale microfibers, which are present in the air both in the heart of Paris and in the remote Arctic. It is known that small particles in the air penetrate deep into the lungs, where they can cause various diseases, including cancer. Factory workers who work with nylon and polyester have demonstrated evidence of impaired lung function and reduced lung volume caused by plastic polymers. Although there was no widespread occurrence of cancer, they are exposed to significantly higher risks than the average person. Currently, about 300 million tons of plastic are produced worldwide every year, and most of it ends up in landfills. Calculating the exact amount of microplastics in the oceans is hard, but some pessimistic estimates put it at around 17 million tons annually. Microplastic is formed from bags, bottles, any other plastic packaging, car tires, peeling paint. It's found in urban dust and is also washed down the drain after each synthetic fabric wash. They are specially added to shampoos, shower gels, scrubs, laundry detergents, and toothpaste for a better cleaning effect. The sale of glitter and other cosmetic products with plastic particles has already been banned in several countries. Microplastic in the world's oceans is twice as much as previously estimated. Recent studies show scientists used a 100 micrometer mesh instead of the previous 333 micrometer one to filter microparticles from waters off the United Kingdom and United States coasts. This way, they were able to detect smaller particles. These data showed a 2.5 times increase in microplastics. The pollution of the world's oceans by microplastics is significantly underestimated, said Penny Lindeck, professor at the Plymouth Marine Laboratory and head of the study. If the nets are even denser, we will certainly collect a greater number of particles. Scientists from the University of Massachusetts and Shandong University in China studied microplastics in soil and found they are absorbed and accumulated in plants. The study was published in the journal Nature. Moreover, microplastics have long been falling together with rain only in the territories of reserves and national parks in the United States. In a year, enough plastic falls with the rain to produce 123.3 billion plastic water bottles, according to the authors of the article published in the journal Science. The study found that about 4% of all atmospheric precipitation is made up of microplastic polymers. Imagine, 4% of precipitation is microplastic. The amount of plastic is an indicator of human impact on the planet. The more there is, the greater the anthropogenic load. Plastic has created the plastosphere, a new habitat where algae, bacteria, and animals grow, live, and hide on plastic pieces. For example, hermit crabs use plastic bottle caps as shells. Water striders that travel across the ocean surface lay their eggs on plastic debris, and fish fries swim into bottles as shelters, from which they can conveniently observe their surroundings. Scientists have found that in the larvae of the common mosquito, microplastic particles remain in the digestive system even in the adult stage. Thus, Plastic moves from the water to the land and pollutes it as well. In oceans, rivers, and soil, there is already so much plastic that even if humanity completely stops production right now, it will remain in nature for a very, very long time. Although widespread, microplastics remain largely undiscussed. They were first mentioned in the 1970s, but significant studies began only about 15 years ago. The World Health Organization recently said there's no proven threat of microplastics to humans. The organization's staff reviewed 52 microparticle publications and found only 4 met quality criteria. World Health Organization experts noted that current concentrations of microplastics in drinking water are not dangerous, but admitted that knowledge on this issue is still limited. In other words, the organization believes that more high-quality research is needed for a more accurate assessment. Scientist Nana Hartmann from the Danish Technical Institute noted that after microplastics were found in beer and honey, critics claimed the samples might have been contaminated during the study. The experts' methods couldn't reliably tell cellulose and chitin from plastic, that is, organic matter from inorganic matter. Laboratories often used microplastic concentrations much higher than those found in nature to observe the effect. Authors of a study reviewed by the World Health Organization found that mice given water containing microplastics developed liver inflammation. However, plastic concentration in the water during the experiment was 5 times higher than in tap water. In the United States National Library of Medicine, you can find about 1,000 articles on microplastics, while the Russian research database has only about 100 publications. While direct harm from microplastics to large animals hasn't been proven, scientists have shown it impacts nature overall.
Small animals eat particles covered with algae or bacterial film, mistaking them for food. The plastic accumulates in their digestive systems, causing them to die, and this in turn destroys the entire ecosystem because plankton is the foundation of the food chain,
says Mikhail Kolobov, senior researcher at Moscow State University's Department of Hydrobiology and General Ecology. Plastic contains toxic substances, dyes, plasticizers that give materials elasticity, and solvents. They can damage the organs and tissues of small animals, but it is still unclear on what scale this happens. Most experiments in nature are done in labs. Particles also act like sponges, absorbing impurities and transporting them far. Some plastics contain, for example, bisphenol A, which mimics estrogen, the female sex hormone. When released in large amounts, it can disrupt animal reproduction, such as reducing blood circulation. Subtitle editor A. Yegorova. Many of us are sure that Baikal is one of the cleanest lakes in the world, but Baikal's water contains 30 to 40,000 microplastic particles per square kilometer of surface. Just like in the rather polluted Great Lakes Huron and Erie, we collect samples on Baikal using special nets that filter particles floating in the water, and the vessel drags them for 1 7/8 miles. The surface layer is the most interesting because that's where the main target for microplastics, plankton, lives. It's finer than in the open sea because waves hit it against the shore, grinding it into tiny particles, says the specialist. Studying the samples in the laboratory takes a lot of time. Scientists are still analyzing what they collected 3 years ago. It's painstaking work with very small objects. Collected particles are preserved, examined microscopically, and analyzed for chemical composition. We then use this data to map lake pollution, the scientist explains. According to him, the pollution of Baikal can't be blamed solely on tourists. The same fishermen buy Chinese nylon nets in bulk for 500 rubles per 300 meters, and then just leave them in the water. Factories and landfills also contribute significantly. Physicist and microplastic specialist at the Institute of Oceanology of the Russian Academy of Sciences, Irina Chubarenko, says that right now, the study of microplastics is going through an era of geographical discoveries. Scientists are searching for its traces and usually find them. According to data from recent years, the Baltic Sea contains about 2 synthetic fibers per 10 liters of water, likely from laundry. These tiny fibers easily pass through water treatment facilities. Chubarenko is studying the migration of plastic in the world's oceans. Our main task is to understand where microplastics accumulate the most. These are exactly the places we will need to pay attention to in the future. Biologists at our institute are studying, for example, how biota, particularly diatoms and other algae, help break down plastic in nature. Filip Sapozhnikov, senior researcher at the Institute of Oceanology of the Russian Academy of Sciences, and his team discovered that the Arctic contains plastic. There's a lot there, much of it hidden under the impassable ice. According to rather approximate data from last year, there is about 1 particle of plastic in 3 cubic meters of Arctic water, which is quite a lot. This year, I'm working with samples collected north of Spitsbergen and Franz Josef Land, taken during the ice. For this purpose, it was specially frozen into the ice for 2 months. Microparticles have already been found in several clumps of microalgae floating under the ice. Such an amount of debris that has already entered the ocean cannot simply be fished out. It needs to be destroyed somehow at the level of ecosystem activity, believes Sapozhnikov. Simply put, the problem with plastic is that cheap things are made from it, particularly packaging for liquids and water, including the fact that if rich countries can afford restrictions, a poor country with a large population cannot. Many people lack access to clean drinking water, so bottling it in plastic is more practical in this case. In 2016, Japanese biologists discovered a strain of bacteria capable of breaking down polyethylene terephthalate, one of the most common types of plastic used to make almost all water and soda bottles. The activity of the enzyme they produce is higher than that of its counterparts, but it's still not efficient enough for industrial-scale use. Scientists are working to increase the effect, so plastic waste can be disposed of faster. And specialists have also discovered worms, or more precisely, larvae of the large mealworm beetle, that are capable of feeding on plastic. Scientists agree that there needs to be control over plastic at all stages of its existence worldwide, from production and use to disposal. Otherwise, it ends up in nature in large amounts. How important is separate waste collection in this matter? And would you separate your waste if you were sure that it wouldn't all end up in the same landfill, but would actually be recycled? We're waiting for your answer in the comments below. Thank you for watching, for caring, and for your interest in this difficult topic. See you in the next episodes on Cremola.